Welcome to Vision Plus and welcome back to this Center for Mathematics and Complex Numbers. We are now looking at properties of modulus. And we are on example 2, which says that we are given three complex numbers, Z1, Z2 and Z3. And then they're asking us to find part A, the magnitude of Z1, Z2 and Z3. So the solution is, remember, we said under properties of modulus that if we are given Z1, Z2, Z3, doesn't matter how many they are, but as long as they are being multiplied and they are under one magnitude, it means that this is the same as the magnitude of Z1 times the magnitude of Z2 again times the magnitude of Z3. So your task is simply to find the magnitude of Z1, find the magnitude of Z2, find the magnitude of Z3, and then you come and multiply those magnitude that you have got. That is when we apply the property of modulus. But there is no sin when you go ahead and you start by multiplying Z1 times Z2 times Z3. You get Z1 times Z2, you get the answer. Use that answer times Z3, you get the answer. And then to that final answer, you find the magnitude of that final answer. It will be the same answer. So let me be here. So I'm going to start by getting the magnitude of Z1. And where is Z1? Yeah, by now you are quicker and you just go direct into substitution. Z1 is here. What is x? Because you remember the formula says that we have x squared plus y squared. Now let me put it once. Now this gives us the square root of what is x? X is the real part of the complex number, which is 3 out of 5. But we are squaring it. Plus, what is y? Y is the coefficient of I, which is 2 squared. Therefore, maybe press your calculator. You're going to say 3 divided by 5, press equal sign, and then you square. It is 0.36. This gives us here 0.36 plus what is 2 squared? It is 4. Then we confirm 3 divided by 5 squared, yes, 0.36 plus 4. It gives us 4.36 square root of 4.36. Then you find the square root of 4.36. This gives us here 2.08. 2.088 881. Or simply you could leave your answer in short form, which is the square root of 4.36. But this and this are approximately the same. And then we go to magnitude of Z2. How do you find the magnitude of Z2? We come to Z2. It is the same as the square root of x squared. Remember, x is the real part of the complex number, which is negative 4. Negative 4 squared plus y is the coefficient of I, which is a half. 1 out of 2, but we are squaring it. What is negative 4 squared? That is 16 plus what is a half squared? Half squared is 0.25. 1 divided by 2 squared, it is 0.25, which is the same as 1 out of 4. But divide what is convenient for you. And then you add it to 16. Then you have 16.25. We shall have here 16.25. And then you get the square root of 16.25. Is 4.03. 4.0311 units. So we have the magnitude of Z1 and the magnitude of Z2. And then we find the magnitude of Z3. Magnitude of Z3. What is Z3? Z3 is 1 minus 5i. So we shall say here we shall have the square root of x. X is the real part of the complex number, which is 1 squared plus. What about y? Y is the coefficient of I, which is negative 5 squared. What is 1 squared? Is 1. What is 5 squared? Negative 5 squared is 25. So when you add, it will give you 26. What is the square root of 26? The square root of 26 is 5.0990 units. Now, after getting the magnitude of each of the complex numbers, your work now becomes easier. Now, remember we have not yet solved part A. So now, therefore, the magnitude of Z1, Z2, Z3, it simply becomes the product of their magnitude. That means the magnitude of Z1 is here 2.0881 times the magnitude of Z2, which is 4.0311 times the magnitude of Z3, which is 5.0990. Then you multiply them. So we shall have 2.0881 times 4.0311 times 5.0990. This gives us here 42.9200 units. So this is the answer for the magnitude of Z1, Z2, and Z3 together. And then we go to part B. Part B says that we are given magnitude of Z1, Z2 out of Z3. Remember, this is the same as the magnitude of Z1, Z2 divided by the magnitude of Z3 from that second property of modulus. And again, we can apply the first property since we are multiplying the numerators. This is also the same as the magnitude of Z1 times the magnitude of Z2 out of the magnitude of Z3. After reaching here, what you need to just do is substitute for Z1, Z2, and Z3. So this implies that what is the magnitude of Z1 is 2.08. Magnitude of Z1 is 2.0881. Multiplying it by the magnitude of Z2, which is 4.0311. But we are dividing it by the magnitude of Z3, which is 5.0990. And then you press the calculator. 2.0881 times 4.0311 divided by, and then going to part C. Part C says that we are finding the magnitude of Z2, Z3 out of Z1, Z2. This is the same as the magnitude of Z2, Z3 over the magnitude of Z1, Z2. You have applied the property of division of modulus. And now, still you have a product on the numerator and a product on the denominator. So still you can apply the property of product. The magnitude of Z1, the magnitude of Z2, Z3 is the same as the magnitude of Z2 times the magnitude of Z3 over the magnitude of Z1 times the magnitude of Z2, since it is a product. Now you can see that you can cancel out the magnitude of Z2 and the magnitude of Z2 here because it is the same value. And even if you don't cancel it out, you still get the same answers. Remember from our previous work of part A, we got that the magnitude of Z1 it was 2.0881. The magnitude of Z2 was like 4.03110311. And then the magnitude of Z3 was 5. The magnitude of Z3 was 5.0990, something of that sort. Now we just need to substitute here. So that we say now therefore the magnitude of Z2, Z3 out of Z1, Z2. Here now it becomes, what is Z2? Z2 is 4.0311 and time is Z3. Z3 is 5.0990 divided by Z1. Divide by Z1. Z1 was 2.0881. So we are multiplying Z1 by Z2, which is 4.0311. And then from here you press your calculator. This and this are cancelling out since you are dividing. This and this are cancelling out. So it's just a matter of saying 5.0990 divided by 2.0881. And this gives us here 2.4419 units. That is the magnitude in part C. Yes, so this is the solution to example 2.